inverse trig functions requires us to remember what an inverse function is first. So an inverse function undoes what a function does. For example, we've already dealt with some inverse functions where we've learned that a square root is the inverse of a square. So a square root undoes a square. So if we have one function that squares a number, like 3 squared is 9, then we have an inverse function that takes us back to our original answer, so square root of 9, which is 3. With trig functions, our input, or x value, is an angle in degrees or radians. But our output, or the y value, is a ratio. And the ratio has limitations depending on which function we're talking about. Like, for example, sine, the ratio can only be between -1 and 1. For an inverse trig function, the input is now x, because the x and y values trade when you're dealing with inverses. I was going to write that. X and y, or domain and range, trade. Okay, so in this one, the angle is our domain and the ratio is our range. So if we do the inverse of that, we're inputting a ratio, that becomes our domain, and the output is an angle, and that's our range. Okay. First thing I want to help you understand is that inverses and reciprocals are two different things. An inverse for trig functions is not a reciprocal. So when I say that, I'm talking about perhaps if we do the sine of 30, of course we get the answer 1/2. The inverse of that is when we do the inverse sine. Here's another notation for it besides the arc. Oh, we're going to learn that in a minute. This is one notation for inverses, the sine to the -1. So if we're doing the inverse sine of 1/2, we get 30 degrees. So with the function itself, we put in 30, we get out 1/2. We put in 1/2, we get out 30. Reciprocal is like cosecant is 1/sine. That simply takes our answer for sine and flips it over to a reciprocal, but it's still a ratio, it's not an angle. So don't mix those two things up, because for this section we are putting in ratios, getting out angles. We are not specifically finding the reciprocal functions values of the other functions. So try to keep those things separate in your mind. Okay, let's talk about each of the inverse functions. Starting with sine. When we want to find the inverse of sine, we can use this notation, arcsin, or we can use the notation I was just barely using, which is sine to the -1, and that's the one you will find on your calculator. If we look at the handout that we're given for this, you'll see right here we've got some details about arcsin, and it tells us that the domain is from -1 to 1, and the range is from -π/2 to +π/2. Let's talk about that for a minute. To explain this to you, let's start with the graph of sine. And remember what that graph looks like. So the graph of sine looks something like that, right? And of course it keeps going forever. If we try to do the inverse of that graph, x and y trade, we end up getting a graph that looks like this. we're saying that these are functions. What's wrong with this being a function? Obviously it would fail the vertical line test. So that can't be a function exactly the way it is. In order for it to be a function, we have to restrict the values that we get out of it. So we have to restrict the range. We're actually going to restrict the range for sine to just this little portion from here to here. Okay? So for our x value, that means we're going between -1 and 1, because remember that x and y have traded. For our y value, we're going to pi halves one direction, so that this area here is in quadrant 1 of the angles in our unit circle. And we're going to negative pi halves the other direction, and these values from 0 to negative pi halves are when we go clockwise on the unit circle down into the fourth quadrant. So we're talking about these angles in the unit circle here, and these angles in the unit circle here, okay? Don't confuse the fact that these are fourth quadrant angles with the fact that in this graph, that's the third quadrant. That might be the third quadrant of our graph for this inverse sine, but it is not third quadrant angles. It is fourth quadrant angles listed as negative values, okay? So this is actually going to be quadrant 4 angles. Alright, so since our domain and range have traded, that tells us that our domain for this function is going to be from -1 to 1, because that is the range for the sine function. The range for this function is going to be from -pi halves to pi halves. For the actual sine function, the domain is all real numbers, but when we trade them, we cannot have all real numbers or it won't be a function. So we restrict it to just the numbers from -pi halves to +pi halves. And in other words, we're restricting our answers to only be in quadrant 1 and quadrant 4. Right? So if our x value is positive, our answer, our y value, will be in quadrant 1. But if our x value is negative, then our y value will be in quadrant 4. And not only will it be in quadrant 4, but we will list it as a negative angle from -pi halves to 0, or from, if you're doing in degrees, -90 to 0. So the answer would be negative. Okay, let's maybe look at a couple of examples of that. So if we do the inverse sine, of 1/2, we did this one earlier, that means our answer is pi over 6, or 30 degrees, because that's in the first quadrant. But if we take the inverse sine of a negative ratio, then that means we need a negative angle in the fourth quadrant. So this is a 45-degree angle, so that was -45 degrees, or in radians, -pi over 4. Let's go to cosine next. Arccosine, so inverse cosine. For the inverse cosine, we're taking the piece of cosine that, okay, let's see what cosine looks like first. Cosine looks like this. For our inverse cosine, we're just going to use the piece of the graph that goes from here to here. So in this picture, it's from there to there, and then when we trade x and y, it's this direction instead. Okay. So again, this is 1 and -1 for our x value. And then for our y value, we're at 0 here, and pi halves here for the positive values, and pi from pi halves to pi for the negative values. So this time we're going to be dealing with angles in quadrant 1 and angles up here for the negative values in quadrant 2. By the way, as I'm using these graphs to help you understand, be aware that we are not going to be graphing in general these inverse trig functions. I'm just using it to help us understand the trading x and y. Domain will be the same from -1 to 1. Range, though, we're using a different piece of the graph. So instead of it being from negative pi halves to pi halves like it was for sine, we're actually going to go from 0 to pi. So what that means is for x values that are positive, we're going to have an answer in quadrant 1 again. So that's easy. Quadrant 1 is always for the positive x values. We get our positive y values. But this time, if x is negative, we actually get a positive y value in quadrant 2. And that answer will be positive anywhere from 90 to 108, or pi halves to pi. So that's different than sine, because when we plug in a negative x value, we get a negative y value. But when we use cosine, inverse cosine, when we plug in a negative x value, we get a positive y value. It's just a bigger number. All right, tangent. For tangent, we're just going to take one of those pieces between the asymptotes. So let's just use that piece right there. Remember, we have an asymptote on each side of it. So for inverse tangent, we are going to have this piece here and that one there. So we just traded our x and y values for one piece of the graph between asymptotes. So the domain of that one, look at our x value, is going to be all real numbers. We can plug in anything because the ratio for tangent can be anything. The range, however, we are restricting to one branch of the graph between asymptotes. And this particular branch of the graph between asymptotes goes from negative, I've already made a mistake here by putting a bracket. It's going to be from negative pi halves to positive pi halves, but I'm not using a bracket this time because remember how there's an asymptote at pi halves and an asymptote at negative pi halves, so those answers cannot be included. And if we try, there's no way for us to get those answers. No matter what we plug in, which can be anything, our answers will always be between negative 90 and positive 90. Okay, so notice how these are kind of the same values as we had for sine. That means for our x values that are positive, we're going to have a quadrant 1 angle for y. And for x values that are negative, we're going to have a negative y value in quadrant 4. Alright, so just like sine, if we do some examples of that one, if we plug in tangent of, let's do square root of 3, inverse tangent, sorry, of square root of 3, we're going backwards, that takes us to a pi over 3 reference angle, right? And if we plug in a negative ratio, like -1 for example, that's going to give us a negative answer of hypotenuse, or negative 45 degrees. We never did do some examples of cosine though. Cosine is the one that's weird, because both sine and tangent, arcsine and arctangent, are in quadrants 1 and 4. But cosine is the oddball. Cosine is in quadrant 1 or quadrant 2. So if we're finding the cosine, inverse cosine of, let's let's do square root of 3 over 2. That's easy. That's just 30 degrees, which is pi over 6. But here's the important one. If we do the inverse cosine of a negative angle, or negative ratio is what I meant, then we do not get negative pi over 4 like we would for sine. Instead, we get pi over 4 in the second quadrant, which is 3 pi over 4. Let's try another one. So the inverse cosine of negative 1 would be 180 degrees, or pi. And the inverse cosine of 0 would be 90, because the cosine of 90, or pi halves, is 0. Let's do one more. How about the inverse cosine of negative 1/2? That would be a 60-degree reference angle, so pi thirds, but because it's negative, it would not be in the first quadrant. So in this case, instead of doing fourth quadrant like negative pi over 3 or negative 60 degrees, we would actually need to go to the second quadrant. So negative 60 degrees, or a 60-degree reference angle in the second quadrant, would be 120, which is also 2 pi thirds.